This question says two white marks are made on a car tire by a parking meter inspector. One mark is made on the outer edge of the tire. The other mark is made a few centimeters from the edge. That doesn't mean three. We have to interpret it based on the graph that we see there. The two graphs show the relationship between the heights of the white marks above the ground in terms of time as the car moves forward. Based on the graph, fill in the chart. Well, the first thing to keep in mind here is that the black mark, this is the mark 1, is going from 60 down to 0. And the other mark, mark 2, is going between 10 and 50. And so when we go ahead and we write the diameter of the circle the mark makes, the mark 1 goes from 0 to 60, so that's 60. And then the other mark going from 10 to 50 is going to be 40. Now the equation of the axis is the same for both of those. It's the center of the wheel. And so that's going to be at a height of 30 centimeters because the outer edge is going to go up to 60 and all the way down to 0. 30 above and 30 below that. So that's going to be the same for both of those marks because that's the middle of the wheel. The next thing is looking at the mark radius. So how far it is from the center of the wheel, the equation of the axis, up to the max or down to the min. And so in the case of mark 1, it's 30 centimeters. In the case of mark 2, it's 20 centimeters. Now we look at the period that this takes to go all the way around. Well, you can see that regardless of what function it is, they have the same period because they're going to take the same amount of time because they're at the same point on the wheel to go all the way around. So the period is 0.25 seconds to get from a minimum to a minimum, and then another 0.25 seconds to get the next minimum, etc. The circumference that the mark travels is going to be different because the inside mark is going to go less distance than the outside mark. But the circumference is always measured by taking pi and multiplying it by the diameter. So pi times 60. We end up getting a value of 188.50, and that's units of centimeters because this is a height of the mark in centimeters. And to calculate the circumference of the second mark, the diameter of that was 40, so pi times 40, which gives us 125.66, again, units in centimeters, 125.66 centimeters. So now we go ahead and we figure out the speed of the mark. Well, how do you find the speed of anything? Well, speed is simply distance over time. We see that driving down the road. We see kilometers per hour, so distance over time. So that means that if I'm finding speed in this case, the distance I can think about is the circumference because that occurs every period. That's a distance, circumference, and the period is a time. So I can make my speed my circumference divided by my period. So my circumference is 188.5 divided by a period of 0.25. And it's important to keep the units in mind here as well. It's centimeters per second. And that's going to give us 754 centimeters per second. 754 centimeters per second. Now to change centimeters to meters, we could divide by 100. And so this would give us 7.54 meters per second. We do the same calculation with the second mark. And because it's more inside on the wheel, it's going to move slower. So we have a circumference that's smaller divided by the same period as the other value. And so we end up getting a value of 503 centimeters per second. 503 centimeters per second. Again, 5.03 meters per second if you were to do that. So the thing to keep in mind here, and just it might be helpful to see a picture of the wheel. The wheel goes from 0 all the way up to 60. And then we have this, the equation of the axis is right in the middle. And then we have this mark on the wheel. And that mark is going to go around, not quite down to the ground. It's going down to 10 and it's going up to 50, down to 10 and up to 50. And so the closer you are to the inside of a wheel, just like a merry-go-round if you were on a playground as a kid, closer you are to the middle of the merry-go-round, the slower you're going, because if the further out you go, the more distance you have to travel, the bigger circumference in the same amount of time, the same period. And so that's why the speed of that inside mark is going slower, has less ground to cover in the same amount of time. So if you're ever on a playground again and you're on a merry-go-round, if you want a thrill, go as far to the outside as possible. If you're not up for thrills, either don't get on or go close to the middle. I hope that was helpful. And if you want to know more about how to analyze graphs of sinusoidal functions, check out the video on the left. For lots of videos about sinusoidal functions and the unit related to that, you can check out the playlist on the right. Thanks so much for watching.